Let's see how we did on this. So the first one here, the degree is 6. The leading coefficient is positive, and a lot of times I just like to make little arrows here to help me remember what to do when I put it in the correct notation. So since it's positive, it's going to have the same end behavior, and it's an even function, so it's going to be up, up. So as x approaches negative infinity, f of x is approaching positive infinity, and as x approaches positive infinity, f of x approaches positive infinity. It's going to have 6 zeros. At most 6 of them are real, and it's going to cross that x-axis at most 6 times. So if I wanted to make a sketch, I know it would start up and it would go crossing that x-axis. Let me just make a quick sketch. 1, 2, 3, 4, 5, 6 times. So 1, 2, 3, 4, 5, 6 times. Is that the correct sketch? Probably not. I just made a really general sketch there. On the other one, we had a degree of 3, and it was a negative coefficient. So it starts up, ends down. So end behavior, as x approaches negative infinity, it approaches positive. As x approaches positive infinity, f of x approaches negative infinity. Number of zeros, 3. At most, 3 of them are real, and it crosses the x-axis at most 3 times. Some people forget, hey, which way is which for odd powers? So always go back to something simple, like y equals x to the third if you forget. So if I had x is negative 1, what if I plug that in there? Y equals negative 1 to the third. I get negative 1. If I get x equals positive 1, I get y equals 1 to the third, which is 1. So you notice, hey, it starts at negative 1 and then it goes up to positive 1. So odd in a positive exponent, positive leading coefficient is down, up. Whereas here, odd in a negative coefficient is up, down. That's just a little trick in case you get stuck which one's which.